From here, it's interesting how things grow. Once people knew that we were getting into doing isolation of instrumentation, they said to us, do you fellas know how to make instrument valves? High pressure instrument valves. Well, we didn't know much about that, but we found out by working with the people down in the Gulf Coast and overseas, what is it you're looking for? They're looking for a 2,500 pound class valve, a valve that has positive shutoff, quarter turn, full port, routable for cleaning purposes, fire safe. Safe is a very important thing, which we'll talk about with this again. Safety is a very big issue, and the ability to make whatever the customer needs as far as special ends, special lengths, special materials, okay, metallurgy, and of course different seats based upon temperature, pressure, the material that we're working with. And still don't forget, this is an instrument valve. You do get fluid going through those instruments and through the instrument line, so you do see slurries, you do see some things. So this is a shutoff valve, an isolation valve, and that's what the instrument valves are for. So we worked on this. We worked on this valve with people from Fluor Daniel and from other engineering firms to develop this for PBM. What we developed was a very simple, actually all welded valve, two-seated, fire-safe, full port, routable valve that incorporates different lengths, different metallurgy, different ends, threaded by male, football flange by a regular flange. It didn't matter. This is what we developed as an instrument valve. What is unique about this was, which no one else had, gotta remember, this is an instrument valve that it has to open and close possibly maybe 6 times in its entire life. And it better work because this is all welded. You don't want to have to take this valve out because it's blocked or clogged or anything else. You want this baby to work. And so what we ended up doing was designing the internals such that the valve incorporates, this is the fire-safe seat, incorporates a fire-safe seat on one side and the other, 2 fire-safe seats, so that when the Teflon seats that are in here expire because of the fire, the ball will rest on this seat. What is also interesting is that most of these people on these valves, especially down on the Gulf Coast in hydrocarbon, will rod the valve out. They will take a drill with a long Rodout tool with a knife blade at the end, very thin knife blade, and they will open they will attach the Rodout tool to the back of the instrument valve. It will go through the valve, through the barrel of the valve, so it's gone past both the seats, and it will be used to clean this out, because here's where it's attached to the pipe. The Rodout tool will be used to clean the body, the seats, the ball, and the barrel out, all the way into the process side. Right? Many times it gets this pipe, this tubing, or this the hole through the valve will get clogged up. It's only a 0.41 inch hole. It's a half-inch valve, 0.41, which is tubing ID. Okay, a little oversized tubing ID. All right, but it's small enough that it will, because everything is sitting there as it goes to the instrument. Everything is sitting there. It will dry out, solidify, and now you've got a blocked valve. So that's the reason they rod these valves out. But when they do that, if you don't protect the valve seats, that seat right here, if you don't protect that valve seat, when I'm running a Rodout tool through the valve, what's going to happen? That drill is running at 1500 RPM. That knife blade is going to cut that ID of that seat. It can't help it. It's just going to cut it because that's the part that is exposed to the process when the valve is in the open position. It's just going to whack it away. And this is one of the biggest problems on instrument valves down in the Gulf Coast, on platforms, on piping systems, and refineries, wherever it might be, is this. This is the biggest reason they literally throw their valves away, because they've tried to clean the valves out and they destroyed the seats. Okay? What we did, and we love this because we install these fire-safe seats so that when there's a fire, this Teflon if it expires and burns away, right, we said the ball is going to sit on it, and that's exactly what it's designed for. That's the fire-safe metal seat that seals the valve. But if there is no fire, I still have this seat in normal operation sitting on that point, sitting on that crown, that raised seat. When I go and rod this valve out, what does that Rodout Tool see? It sees the fire-safe seat. It sees the idea of the fire-safe seat. It goes right through from the fire-safe seat into the ball, into the other fire-safe seat, and straight out through the barrel. That rotating blade never sees the ID of that Teflon seat. One of the best features we ever put in these valves, and it has really caught on. People really appreciate this because suddenly they don't have to throw away their valves. They don't have to get rid of the instrument valves. These things will last, okay, and they like them. And again, what we did, of course, was we included on all of our instrument valves this locking handle. Again, they like it because, again, that's one of the biggest faults or problems they run into down in the Gulf, and that is that people crawl all over these platforms. They crawl all over the refineries, the distillation columns, the cokers, all of that, and they're using valves and piping, anything, to use as things to stand on. And you know what they stand on? They stand on handles. That's what they stand on. And if that handle moves, you don't know where that instrument's going. It could be saying, oh my God, we have to shut the process down because the temperature's gone too high. No, it hasn't. Someone just kicked the handle and sent a false signal. So holding that handle in the position that it should be in, open or close, is of prime importance down there. Safety, what I said at the beginning, safety is most critical in all the designs that we look at. Okay, so that's that. Now, it's interesting what happens once you've developed a valve such as this. People say, well, can you do a double block and bleed? Double block and bleed, ladies and gentlemen, is a valve that is typically two valves in a single body with a bleed in the center. Now, where would that come from? Well, the problem again is safety, safety, and safety. If you're dealing with either instrumentation or process lines that are handling materials that could cause harm to people, such as high pressure steam, toxic gases, toxic liquids, hydrocarbons at high temperature, all of those things that if people are involved with them on a regular basis, such as instrument lines, a single valve could be a problem. For instance, if you shut a toxic chemical instrument line off and a man has to fix an instrument, that valve may or may not be sealing. Doesn't take much to have a leak in a valve, in a ball valve, quarter turn. That leak, once he took the instrument off, could cause damage to that person, to the instrumentation. It could be a problem. So they said, okay, let's take two valves and put them in series, one right after the other. That makes sense because we're sure that if one doesn't hold, the second one will. It gives you two chances of blocking that flow. That's fine. So now you've got double block. What about bleed? Well, the bleed is there so that once you've isolated both, all right, now you've got this material trapped in the center section between the two balls. We must relieve that to make sure that that is not going to be in the valve when we go back to turn it on again. Right? So we want to get rid of that. So what we do is we put a port in the center body between the two valves, and possibly we either run it out by tubing or possibly we put a valve there, whatever the client, whatever the customer wants, whatever the site demands for their own protocols. But a double block and bleed looks like this. Remember, here's a single block valve. Okay? Here's a double block. Two valves. 1, 2. Two balls. 1, 2. Isolation. 1, 2. And bleed, this right here is your bleed port. This one happens to have a a bleed, an automatic bleed for a gas system, okay, just to the atmosphere, all right? But normally you could take it out, you could remove that, take a tube to a reservoir, tube to some other area, tube to an enclosed vessel, or you could put a valve here for drain to control that. It would be 1, 2, in effect, 3 valves. Here again, the way PBM makes them, we're very much in tuned to what? Size. Size. Keep it small. Keep it compact. Reduce the size. Reduce the weight. Ends, we don't care. Notice these are now compression ends versus female or male, flanged, whatever it might be. We can put any end that the customer wants, that the site would use on our valves. We can mix, we can match. But one more thing, notice what else is important on here. We said it before, safety. What do we have? We have the locking handles to make sure that those valves are either open or closed, whatever it might be. The valves can also be made so that you can mount actuators. So you can have an actuated valve on each side if you want. You can have an actuated valve with a manual valve. It doesn't matter. The point is that what we're saying is we can, typically with our differentiation, our engineering capabilities, we can take your problem, come up with a solution, and create a double block and bleed instrument valve for you. Now, what happened with this was, once we were doing this size, which is a 1/2 inch, of course the next thing that people want is larger. Presently we can build the double block and bleed valves up through 12 inch, full port. Now obviously as you get up in size, the pressure ranges will be coming down. A 1/2 inch valve, 2,500 pound class valve is a 6,000 to 10,000 psi valve. When you go up into the 12 inch, you're dealing with 150, 300 pound max, which is, say, 720 psi. So what happens with this type of a valve, like any valve, is that as you go up in size, many times the pressure class has to come down. But to give you an example, with these 1/2 inch, 3/4 inch, or 2,500, 1 inch, 1.5 inch, you're looking at around 900 pound. When you get up into the 6 inch class, we're talking 600 pound class. 600 pound class valve is still 1350 psi. So you're still covering a large range of pressures. Not only do you have to look at that, but now you've got to think about the metallurgy. You've got to think about what it is that's going through this valve and what it is that is going to be compatible with the fluid you're working with. Temperature is a very critical thing. Temperature obviously is going to determine, again, sometimes metallurgy, but most importantly, it'll determine the seats you're using. Different seats will sustain themselves in higher temperatures, but not necessarily be a good shut-off valve. It won't be soft enough to seat. So you've got, for instance, as you go up into higher temperatures and pressures, many times you're going to metal seats. Metal seats are used in place of the softer Teflon or other soft material seats, but metal seats allow you to go into higher pressures, higher temperatures, okay, and also the ability to handle solids. Now, why would I care about solids on these kinds of valves? Well, first of all, what's happening is that this valve is no longer being used in just instrumentation. These are now process valves. It's interesting to note that the process side of double block and bleed really started in Europe a number of years ago. On the North Slope and North Sea and all those areas, on the platforms and areas where safety, that idea of safety was critical. And the typical piping arrangement in most applications where you're dealing with instrument bridles or just process lines coming off of a reactor or coming out of a tank, you will normally have two very large high pressure gate valves or globe valves in series, one after the other, and right in the middle between them will be a piping T, and then off that T will be a similar valve, similar pressure class, maybe smaller, okay, on that T. So suddenly you find yourself with a piping solution that may be this size or twice the size of this table, length and very, very heavy because let's say it's a 600-pound valve. A 600-pound valve could weigh as much as 1,000 pounds. And so you've got 2,000 pounds of those deblocking valves, and then you've got another 300-pound valve over here that's a 2-inch 600-pound valve. So suddenly you're dealing with size, you're dealing with weight, and obviously you're going to be dealing with cost, because the cost of installation, the cost of maintaining, the cost of buying them, and the delivery is also very, very long and very costly. So those are some of the problems. Shipping something like that on a skid, whatever it might be, that weight causes stress on piping, stress on vessels, all sorts of things. So why do you go to double block and bleed? Well, if you can take that concept, the same concept we had here, and move it down into a smaller package, which you can. Rather than having 2 individual valves, you create a block or a body with 2 balls in it, with a bleed at the bottom of the body with another valve. Same class, but it could be a ball valve. But suddenly what you found is you're dealing with on a 6-inch valve, that 6-inch valve could be no more than 18 to 24 inches long. All right? And probably about on 600-pound valve is probably going to be say 12 inches wide and maybe 12 inches high. So suddenly you're dealing with something that's very compact, weighs most likely about 1/3 of what the other configuration was. And the cost, though you think that it may appear that the cost of that double block and bleed, that seems expensive, when you add up all the components and the time of installation and all the rest of that, all the other factors I mentioned, suddenly you realize that this double block and bleed idea is a pretty good idea. Okay. Now, again, as I said, even on the safety side is very important. The ability to provide information, traceability, metallurgy, all of that on the components that you're using to make sure that that integrated valve is exactly what it has to be, exactly what you expected it to be, from the pedigree of the valve, from the way it was manufactured. All of that, it is another part of the safety picture you're looking at. But that is where we have shined. Another very interesting point is that if you're using that concept of the 6x6x3 idea with the T and the rest of that, and that's on an instrument bridle going to a reactor. Don't forget, these instrument bridles are not dealing with fluid flowing. They're using this instrument bridle to feed typically a vertical instrumentation column upon which all the instrumentation is hung, and then these 2 instrument T's, those big valve packages, go over and mount to the side of a tank. A lot like the way these mounted to the tank, high and low, okay? But think about that. You've got a reactor with these 2 huge, 8-foot long piping configurations, one above, one below, sitting out there, and you've got this poor little 1-foot diameter instrument tube with a lot of instrumentation stacked on it because they don't want to put it on the reactor. It's sitting out there and it's doing this. It's coming over on a ship, back and forth. What do you think is going to happen? You're going to have a lot of pipe stress, you're going to have a lot of leaks, all the rest of that. Plus it's just in the way, especially when it's installed into a refinery. It's just too big, it's too much. It's not necessary. And so what we end up doing is we talk to the site and we say, look, all you're doing is trying to measure instrumentation. You're just using it for a dead-end control to this dead-end tube, static tube, where you're monitoring temperature, pH, pressure, not flow, because it's not a flowing instrumentation column. So you've got all those things. You don't need this big thing. So why not just provide enough of the fluid flow from the tank or from the reactor to the tube to make everything work? So what you find suddenly is that these big 6-inch valves were only supplied because someone put a 6-inch connection on the tank. They were really never required. No one needs to flow 6 inches into a 1-foot diameter standing pipe. So why not reduce it all? Put a 6-inch, 600-pound flange onto a 600-pound body that has a 1-inch hole through it. In other words, valves that are 1 inch in diameter. 6-inch inlet, 600 pound, a 6-inch 2-valve manifold, and a 1-inch 600 pound flange going to the vertical tube. That makes a heck of a lot more sense, and it addresses the problem directly as to what you're trying to do. Not be carrying this weight and this tremendous cost and all the rest of it for something that no one thought of in the past. So this is what we do. We think about these problems, and we think about the solution, and we come up with a solution like that. That particular thing we've done. We did it recently for a major refinery, 400 manifolds and various metallurgies. These are all 1,500 pounders, and they were supplied on these reactors for controlling or for working with the instrument bridles. A super successful application, and it changed the refinery's concept of the big 3-valve piping configuration to, oh my God, we can do it with just something small and simple. Why didn't we think of this before? This is what PBM does. This is how we can help. This is the beauty of PBM's engineering and our experience and our heritage. This is what we love to do. We're valve people, and we're all engineers, and we love to do this. So I say to you, consider all that we've done with PBM. These are just some of the many ideas that PBM has come up with. The point is that we are differentiators. We are innovators. We want you to come to us to bring your ideas. Doesn't matter if it's on the back of an envelope, on a napkin, or on a beautiful CAD drawing. It doesn't matter. Send it to PBM. We will sit with you and come up with a solution to your problem. That's the important thing. We're not just saying it. We've been doing it for 113 years. That's why we're still here. So consider us. Thank you very much for helping us. Now, I would like to suggest that if you do have an opportunity for PBM, we have something called a customer inquiry sheet. This is important, as you can imagine, on valves like this. All we're asking for you is to give us some basic information, just basic information, pressures, temperatures, fluids, what it is you'd like to achieve, just an idea. It doesn't have to be so specific, but just something that when we talk over the phone, talk via email, we know initially where you're coming from, so we can address the problem right away without wasting a lot of time, because we know that time is money for you just as it is for us. So please, if you're considering PBM, please contact your PBM representative or contact our factory direct and get this filled out and get it to us, and we'll be more than happy to help you out. Thank you, and have a great day.